Gyronix.
Okay, welcome back to this laboratory exercise 9. So this time we will showcase the usage of an array. The given problem for this exercise is actually came from our laboratory exercise 6. So you can check that out. The program that converts the decimal number into the binary. So the laboratory exercise 6. So we are asked to make a C++ program that converts decimal to binary. Okay, so the program will ask the user to input the decimal number, let's say 7, and it will display its binary equivalent. But this time, we will be using the array, okay, for this exercise. Okay, so let's open now the CodeBlocks IDE. And now let's open the laboratory exercise 6, the decimal to binary. Okay, so let's open the project file. So this one with .cbp extension. Okay, so open that up. Okay, so let's program this one. The first thing we will do here is to remove this storage. So we have 8 bits. We'll replace this with an array. Okay, so let's remove these 8 bits. We don't need this counter anymore. Okay, so let's create an array. The type, of course, integer, and let's call it bit. The number of elements is 8 since we have 8 bits. Okay, so let's have that empty. Okay, no initial value. Okay, so we have now an array that can store 8 values, which is integers. So that will be the storage of our bits. Then for the this one, okay, the while. So let's replace this with for loop. Okay, up to the, okay, so this one, all of it. Okay, the switch. So this is the closing, this is the opening. Okay, so all of it. Okay, so let's create this again using for loop. Okay, delete. So let's set up now the for loop. Okay, so we have for opening close parentheses, then the braces. For the for loop, so let's have a variable I. Let's declare that one with initial value is 0. Actually, this I will be the index of our array. Okay, and we will iterate this loop as long as the I is less than or equal to. So we have 8 bits, but take note the array index starts with 0. So the maximum number is 7. Okay, so again, the array starts at 0. So from 0 to 7, that is 8. Okay, so we can count that as 8. Okay, 8 bits. And of course, we will increment this one. So to determine the binary equivalent of the number, so in this case, we store it in the decimal number. We divide it by 2. But we are extracting the remainder, and we are storing that now to our array, which is the bit. Okay, the name of the array is bit. The first division, which is also the LSB, the less significant bit, we will store that to bit 0. But since we are incrementing this one, as you can see, so the I will start at 0, it will increment. So it will 2, 3, 4, 5 up to 7. Okay, so which means this one will be our variable. So the first division will be stored to bit 0 or index 0. The second division is index 2, of course, since we are incrementing the for loop. And we are updating, of course, the storage or the value of decimal number, which is the quotient, okay, of the division by 2. So this is the quotient. and this is the remainder. Okay. So as you can see, we replaced that 20 lines with just this 4 lines of code. And we'll update, of course, the output. So for the output, we'll be also using the for loop. Okay, so we have for. Okay, so another variable. This time we will start with the most significant bit, so which is 7. And it will increment as long as your I is greater than or equal to 0. Since this time we will be decrementing this value. So why? Because the last bit will be the most significant bit. Okay, so we have now Cout. Okay, the bit, of course, I. So that is the index number. It will display the last bit. Okay, it will start at bit 7. Okay, the index 7. That is our MSB. Okay, so let's try this out. Okay, so build expected semicolon. Where's the semicolon? Okay, here. Okay, so okay, build. Okay, run. So 255. Okay, 55 is 1111. So it is 8 bits. Okay, so yes. So let's try 8. Okay, 100. So yes, 150. Okay. Actually, we can separate. So as you can see, this one, it's harder to read. So let's say we will separate every 4 bits. So to make it easier to read. Okay, so now we can add the for loop. We can say if let's say the I is equal to the 4th bit, the index 3. Okay, if the I is equal to 3, meaning that is the 4th bit, so we will output a space. So space. Okay, so let's try this out. Okay, build. Okay, so let's try to run. Okay, so number is 255. Okay, so that's our space. So yes, 9. So 1001. Yes, 150. Okay, so it's much clearer to read. Okay, with the spacing between 4 bits. Okay, so 7, of course, enter wire and only. Okay, so I will exit now the program. Okay, so we're done. Okay, we replace those long lines of code using only this one. Okay, so this is the effect of using array. So instead of we have that 8 bits variables, so we replace that with one array only. Okay, which have 8 elements. Okay, so this is the end of this exercise. So see you on exercise 10.